Hello, welcome back to class. In this episode, we're going to be talking about transposition of formula. A formula is an algebraic relationship between two or more variables or quantities. In the formula y equal mx plus c, we say that y is its subject. To change the subject of the formula is to rewrite the formula so that another letter such as m or x or c takes the place of the y. To make sense of this topic, and many students have challenges with it, the student should be able to solve basic equations, be able to factorize, and be able to work with powers and roots. In this lesson, I will try to take you through the basics of the techniques that you need to successfully change the subject of a formula. There are quite a lot of examples to look at, and so we're going to get into them immediately. First, we're going to talk about how to transpose a linear equation such as this. Linear means that everything is in a straight line. Before we answer this question, though, we want to make x the subject. First, we want to solve this equation. Now, how do we solve the equation 3x plus 9? Well, we realize here that we're adding 9 to our 3x. So the first thing we would do is to subtract 9 from 20. So we end up with 3x is equal to 20, take away 9. Now 20 take away 9 is 11, but I'm not going to write down the 11. I'm going to leave it as is for now. The next step we would do is that since the question now says 3x is equal to 20 minus 9, we want to find out how much 1x is. And to do that, we would divide both sides by 3. So 3x over 3 would be equal to 20, take away 9 over 3. And so, having divided out the 3, we end up with x is equal to 20 minus 9 over 3. Here, we can say x is the subject of the solution. Let us apply the same technique over here. We want to make x the subject of this expression, this equation, which also means we want to solve this whole equation for x. So the first thing we want to do probably is to move this by. Now this says ax plus by, so we would need to subtract our by from both sides. That means we're going to be left with ax is equal to c take away by. Now that we have this, our next step would be to find what x is. In this equation here, we had 3x equal to 20 minus 9, and now we have ax is equal to c minus by. So to finish our answer, we're going to divide, as we divide here, both sides by 3, we're going to divide both sides by a. So ax over a is equal to c minus by over a. Doing our division, we end up with x is equal to c minus by over a. And we have finished this question. We have successfully made x the formula. In this formula, c was the subject. Now we have changed it so that x is now the subject. Let's look at another example. Given that s minus 3t equal rt, express t in terms of r and s, which means we must make t the subject. Let us look at this corresponding equation first. When we're solving an equation that has x's on both sides, our idea in solving it is to regroup. So we are going to regroup the x's on one side of the equation. Here we have the left-hand side, and here we have the right-hand side. In this question, we're going to regroup the x's on the right-hand side. Since this 2x here is being subtracted from this side, we're going to add a 2x to both sides. Adding the 2x to both sides gives us 5 is equal to 7 plus 2x. Here, the minus 2x and the plus 2x would give you 0, so I won't bother to write it. Note that we have the x's on the same side, 7x plus 2x. We can combine these two x's together to get 9x. However, I am not going to do that. What I'm going to do instead is to factor out this x. I know it sounds weird. Nobody does it that way, but I want to make a general point so that you'll see something later on. So 5 would be equal to, x is a common factor. I'm going to take out that x and write 7 plus 2. Now you know that 7 plus 2 is 9. Now, we want to find what x is. And since we have that this bracket multiplied by our x gives us 5, we'd want to now divide by our bracket. So we are factoring here, and now we want to divide by our bracket. So 5 is equal to x bracket 7 plus 2, and we're going to divide by the bracket which is 7 plus 2. Yes, we're dividing by 9. But I'm keeping it in parts so that you will see the idea of it later on. Having divided by this 7 plus 2, our answer therefore becomes 5 over 7 plus 2 is equal to x, or x is equal to 5 over 9. Now let's try and walk this technique through this question. So s minus 3t is equal to rt. In this question, we have the 3t here and rt here. So we need to group our t's on the same side, which means we're going to group the minus 3t with the rt. That gives us s is equal to rt plus 3t. In this case here, you could have added 7 plus 2 and gotten 9. But in this case here, we cannot add them because this is r and that is 3. The only solution here is to factor. So we're going to factor it out as we factored out the x here. Now the common factor here is t. So we're going to factor out the t. Write our t, open our bracket, and t into rt gives r, and t into 3t gives 3. Having done that, we now divide by our bracket. So s is now equal to t bracket r plus 3, and we're going to divide both sides by r plus 3. This r plus 3 will cancel that one, which means that we're left with t is equal to s over r plus 3. We have successfully transposed the formula, or rewritten it, or expressed t in terms of s and r. Take a moment to think about this technique that was used here and how it was applied here. When you're ready, move on. Now let's look at more examples. In these two questions here, we have fractions. And when we have fractions in a question, the way we deal with them is to first get rid of the fraction by multiplying throughout by the LCM. So let me write that at the top. Multiply throughout by the LCM. You do not necessarily need to use the LCM as in the strictest form, but we're going to just multiply this 3 times this y, and that will give us our LCM. Multiplying 3 times y, 3y, so we're going to multiply everything in this question by 3y. So 3y multiplied by 2x over 3 plus 3y times 4 over y equal 3y times 1. The purpose of multiplying throughout by the LCM is to get rid of the denominators and to get everything in a nice straight line. So here you will notice that the 3 here cancels that 3. You will notice here that the y cancels that y. What we end up with is y times 2x. We can write it as 2xy plus 3 times y equal to 3y. Actually, this is 12. 3 times 4. Let me correct that. So this is 12. 3 times 12. 3 times 4. Because we wanted to express y in terms of x, we have a y here and we have a y here. We can regroup this 2xy on this side of the equation with that 3y. So we can say 12 is equal to 3y take away 2xy. Having done that now, we notice that we have our y's on the same side. We can factor out our y. So let's factor out y. So 12 is equal to y, open bracket, 3y divided by y gives us 3, and minus 2xy divided by y gives us minus 2x. Once we're here now, we can simply divide by our bracket. So we're going to have 12 over 3 minus 2x is equal to y times 3 minus 2x over 3 minus 2x. This will cancel this. So your answer is going to be y is equal to 12 over 3 minus 2x. We have made y the subject of the formula. Let's try that same technique here. Here now, your LCM is going to be RVT. So we multiply everything in the question by RVT. We are going to make t, this small t, the subject, this one. So we say R, capital R, V, small t, times 1 over big R is equal to RVT times 1 over V plus RVT times 2 over T. Remember, the idea of multiplying by the LCM is that we want to get everything in a nice straight line, such as this. So here, big R cancels big R, V cancels V, T cancels T. And what we're left with is VT, that's small vt, equal to RT plus 2RV. 2RV. All right. Now that we have it in a nice straight line, we notice that there's a t here and there's a t here. So we need to group our t's on the same side. It is convenient to group this RT along that side with the VT. So because this is a positive RT, we can say VT minus RT is equal to 2RV. And now we factor out our t. So we take our t, open a bracket, Vt divided by t gives us V, and RT divided by t gives us R. That is equal to 2RV. Now we can finish our question by dividing by the bracket. Dividing by the bracket, v minus r gives us t is equal to 2rv over v minus r. And that is how we express t in terms of r and big T. I'm wondering about the question here because I didn't see a big T. It should be r and v. That was an error in how the question was written down. So the question should have said express t in terms of r and v. When you pay attention, when you look at it, it should be r and v and not r and big T. All right. Having done that now, let's look at some more examples that have infractions in them. Make A the subject of this formula. All right. What is our LCM? We can put this b over 1 and our LCM becomes a plus 3. So we multiply both sides by a plus 3. So bracket a plus 3 times b, you could say that you cross multiply it, is equal to 3a plus 2 over a plus 3 times a plus 3, since we're multiplying both sides. This a plus 3 and that a plus 3 cancel each other out. And what we're left with, multiplying out this bracket, is b times a, which is ab or ba, plus 3b is equal to 3a plus 2. We want to make a the subject. Notice that a is here and a is here. So we need to do some regrouping. We can regroup our a's on the left-hand side and everything else on the right-hand side. So we start by writing BA. This is a plus 3a, so we have minus 3a. This was a positive 2, we write it back, and now we subtract from it our 3b. Now that we have our a's on the same side, we can now factor out our a. That will leave us with b minus 3. And to finally get our answer, we divide both sides by the bracket. B minus 3. And we end up with our solution. A is equal to 2 take away 3b over b take away 3. So look at the word sometimes. Previously it says express. Here it said express y. Now it says make a, and then it says rearrange the formula to make q. So the language of the question will change, but you will get the idea of what it's asking you to do. Q is what we want to be the subject. Q here is in our denominator. So we're going to do the same thing we did here by multiplying both sides by the denominator. In this question, it's nice and easy to cross multiply it. We can try that. Or you can multiply both sides by the LCM. It will have the same effect. So we have R, put that over 1, is equal to 2p squared over q minus 3. Cross multiplying gives us r times q minus 3 is equal to 2p squared. Now we need to multiply this bracket out. So rq minus 3r is equal to 2p squared. Remember, we want q to be the subject, so we need to keep this rq. Now since this minus 3r is here, we need to remove it to the other side of the equation by adding 3r to both sides. So now, adding 3r to both sides gives us rq is equal to 2p squared plus 3r. Adding the 3r here gives us a 0. So we want q to be the subject. The next logical step is to divide by our r so that we can get our q. If we divide this by r and this side by r, then these two r's will cancel each other out. And what we're left with is Q is equal to 2p squared plus 3r over r. And so we would have successfully rearranged the formula to make Q the subject. Now, what about when we're dealing with powers? In this question, make r the subject of this formula, v equal 1/3 pi r squared height, h. Then first, we need to get it into a straight line, so let's go ahead and get it into a straight line. We can get it into a straight line by multiplying both sides of this equation by 3. Here, the 3 times 1/3 will cancel out this fraction. So we end up with 3v is equal to v multiplying everything by 3. We end up with 3v is equal to pi r squared h. We want r to be the subject. So here's our r. Now, in a case where you have something like, if you're solving the equation 2x is equal to 10, and you want your x, then what you do is that you divide by your 2. Yes? And you get x is equal to 10 over 2. We want r to be left alone on this side. So the logical thing to do would be to divide by pi h, since we don't want the pi h there. Dividing by pi h gives us 3v over pi h is equal to r squared. At this point, let us talk about another simple equation. Suppose we're solving the equation x squared equal 25. How do we solve it? We would say x is equal to the square root of 25. Well, actually what we write is the square root of x squared is equal to the square root of 25 by taking the square roots of both sides. And the square root of x squared is x, and the square root of 25 would be plus or minus 5. Most of the time, we just write plus 5, given that sometimes we're just talking about the positive root and not both roots. But there are two roots. So in this question, we're going to do that. Since we want r, and this is r squared, we're going to take the square root of both sides. So the square root of 3v over pi h, and everything is under the root sign, is equal to the square root of r squared. Now the square root of r squared is r, so we're going to write r is equal to the square root of 3v over pi h, and that is our solution. Let's try this question. Make p the subject. So the first thing we're going to do again is to cross multiply here or multiply both sides by the denominator q minus 3. So we're going to have r bracket q minus 3 is equal to 2p squared over q minus 3 times q minus 3. These two cancel each other out, and so what we're left with is r times q minus 3 is equal to 2p squared. Since we want p and p is here, we do not have to trouble the bracket. We can leave it alone, since what we want is not in the bracket. But we do need to get rid of this 2. So we need to divide both sides by 2. So let's divide by 2. And dividing by 2 gives us r bracket q minus 3 over 2 gives us p squared. And now since we have our p squared, we can apply this idea here of finding the square roots of both sides. So the square root of r bracket q minus 3 over 2 is equal to the square root of p squared, which gives us finally p is equal to the square root of r times q minus 3 over 2. And all of this is under the root sign. More examples. Now here we have two final examples to look at, and these two have roots in them. So we are told that m is equal to the square root of 1 minus n squared over n, and we have to express n in terms of m. Now, to get rid of a square, we find the square root. So if x squared is equal to 25, then x is equal to the square root of 25. So we take the square roots to get rid of the square. And if we want to put this back into this form, then we would have to square these. So we'd square x, and we'd square the square root of 25. And squaring the root of 25 gives us 25. Roots and squares work in cycle opposition to each other. One undoes the other one. So the opposite of a root is a square, and the opposite of a square is a root. Saying that to say, in this question, the first thing we need to do is that we need to get rid of the root sign. And the way we get rid of the root sign is to square everything. We square everything. So we're going to square m, and we're going to square this side, the square root of 1 minus n squared over n. Squaring this side gives us m squared. And squaring this side in the numerator, the square will cancel the root, which means we're going to be left with 1 minus n squared. But this n was not under the root sign, so we're going to end up with n squared. Notice, the m gets squared, it's not under the root sign. 1 minus n squared is squared. This square will cancel the root. And the n, which was not under the root sign, is also squared. It becomes n squared. So now we have, let's cross multiply here. We have m squared n squared is equal to 1 minus n squared. We are trying to make n the subject. So n is here, n is also here. So we need to regroup the n squares together. Let's keep this m squared n squared here and bring over this n squared so it becomes a plus n squared, and that will be equal to 1. Now we can factor out our n squared. So we can say n squared bracket m squared plus 1 is equal to 1. And now that we've done that, we can divide by our bracket. So we can have now n squared divided by m squared plus 1 is equal to 1 over m squared plus 1. This gives us, writing it up here, n squared is equal to 1 over m squared plus 1. And to finish up our answer, what we do is that we simplify the square root of n to give us n is equal to the square root of everything under the root sign, 1 over m squared plus 1. In this question, our final question, we're going to make p the subject. Now notice in this question that everything is under the root sign. In this question, only the n was under the root sign. So when we squared both sides, the n got a square, while the 1 minus n squared was rewritten as just 1 minus n squared without the square root sign. All right, so we need to square both sides. Squaring both sides, we have r square is equal to the square root of 4 plus 3p squared over s. Notice that the s is under the root sign. We're squaring all this. So this will give us r squared equal to, this square will cancel that root to leave us with 4 plus 3p squared over s. This is a fraction, so we can simply cross multiply here to get r squared s is equal to 4 plus 3p squared. We want our p to be the subject. So we need to remove this 4 by subtracting 4 from both sides. That gives us r squared s minus 4 is equal to 3p squared. And since we have a 3p squared and we want p squared to be by itself, we need to divide by 3. So let us divide by 3. This gives us r squared s minus 4 over 3 equal p squared. And finally, to get our p, we need to find the square root. So p is going to be equal to the square root of everything, r squared s minus 4 over 3. This topic, like I said at the beginning, can be challenging for many students. It can be challenging because the equations are very abstract. But if you take your time and you practice, and in mathematics, it is important that you, the student, be patient with your learning. Do not rush it. Do not become frustrated by the fact that you may not learn it the first time. You must be persistent and continue to practice the questions over and over. This video would have given you a chance to look at different examples and how you approach them. So I hope you use it to find many other questions and practice and practice and practice until your skills are sufficiently developed and you become the master at it. If you're doing CXE and you would like more videos like this, then subscribe. And as soon as the videos are posted, you will be notified. Continue to work hard as you practice toward your exam. Thank you for watching.